Okay, today we're going to go over section 8.7. This is called product to sum and sum to product. So this chapter or this section here will be on your exam, I believe, somewhere in the middle of your test. You'll have product to sum, sum to product. So let me go over. It's very simple. It's nothing hard. 8.7. Product to sum. Okay, so you have formulas for product to sum, and it's titled the way the formulas are presented. So let me show you how the formulas are written. So in the yellow, this is on page 665. You have the product to sum. So notice there's your equals. On the left, you have product. It's sine alpha times beta and equals, and then you have the sum. On the other side, you have plus and minus. Okay, so here are there's three formulas. There actually is four of them. On our formula sheet on our Canvas page, if you go to files under formulas, there's an additional formula for it. So let me write down the formulas. So we have sine alpha times sine beta. I'm going to use alpha and beta. I'm going to give it a shot. See if I can correctly draw the alphas and the betas. All right, so the first one is 1 equals 1/2 bracket cosine alpha minus beta minus cosine alpha plus beta, close. The second one is cosine alpha times cosine beta. That's equal to 1/2 bracket cosine alpha minus beta in parentheses plus cosine alpha plus beta, close bracket. The third one is sine alpha times cosine beta is equal to 1/2 bracket sine alpha plus beta plus sine alpha minus beta. The reason why the book only has two of them is because, multiplication is associative. So you can have sine, cosine, it doesn't matter. It should be the same. But I'll give you the fourth one. So let me give you the fourth one. It's in the formulas on our page, and the fourth one is reversed. It's cosine alpha sine beta is equal to 1/2 parentheses sine alpha plus beta minus sine alpha minus beta. Yeah, they should have put the fourth one on there. Interesting that they don't have it on there. But anyways, so there it is. There is the fourth formula. So again, you don't have to memorize them. Here are the formulas. Right? You have product to sum. And basically all you do is you just plug in the numbers. Okay, that's all you do. You just plug in the numbers into the right side. So let's do an example. So let's suppose that I want to compute. This is in your book page 667. I'm doing number 1. So it says find sine of 195 degrees times cosine of 75 degrees. So all you do is you match it. Okay, so I'm going to match it. I have sine and cosine, so that would be the third one, right? So this is your alpha, and that's your beta. And so you plug it in, right? So it's 1/2 bracket sine of 195 degrees plus 75 degrees close plus sine 195 degrees minus 75 degrees. Right? And then you simplify it. So we get 195 plus 75 is 270 degrees, right? Don't forget the degrees. And then we subtract 195 minus 75 gives us 120 degrees. Okay. And then we calculate it. So we're going to go to your unit circle. And we're going to figure out what is sine of 270. All right. So remember, sine is a y. So let's look at our formulas. Go up to our unit circle. And sine of 270 is the y. So it's -1. And sine of 120, where's 120 at? I need the y. It's right there. It's square root of 3 over 2. Right. And I plug them in. Okay, plug them in. And now I simplified. I think I'm going to go ahead and just distribute. So we get -1/2 plus square root of 3 over 4. There you go. That's what you do. Okay. All right, let's do another one. Let's do I'm gonna leave the formulas there so you guys can jot that down. We do another one. Let's do number 7. Let's do one where we don't have any angles. And they just have variables. So we'll do number 7. So 7 reads sine of 4 theta. It's not 40, it's 4 theta times sine 2 theta. Okay. So these are thetas, not 40 and 20, right? So I'm going to look at my formula. I'm going to match it. This sets times product is going to match the first formula. So I'm going to plug it in. So 1/2 bracket cosine. This is your alpha. This is your beta. So 4 theta minus 2 theta minus cosine 4 theta plus 2 theta. Okay. And you plug them in and simplify the inside. So we're going to get cosine 6 theta, not 66. Oh, I'm sorry, not 6 theta. It's 2 theta. 2 theta. 2 theta. The other one is going to be 6 theta. Cosine of 6 theta. Right. And we can't combine them because they have different variables. This has 2 theta, this has 6 theta, so you cannot combine them. The only way you can combine them is they both had cosine 2 thetas, or they both had cosine 6 thetas. Then you can combine them, but here you cannot. They're different angles. So that's our answer. Okay. All right, so let's do another one. We need to do one where it comes out kind of funky. So let's do let's see if I can find one that comes out kind of freaky. Number 11 is one where it comes out kind of freaky. So let's look at 11. So 11 reads cosine 3 theta times cosine of 5 theta, right? So again, you're going to match it with the formula. So this is cosine cosine, so I'm going to use the second formula. So I'm going to plug it in. This is my alpha. This is my beta. We plug it into our formula. Cosine 3 theta minus 5 theta plus cosine 3 theta plus 5 theta. Making sure I wrote it right. Okay, now I want to simplify. So I'm going to get 1/2. I'm doing the insides, right? So this is going to be negative 2 theta plus cosine 8 theta. Right. So you think you're done? No, we can't have a negative angle inside a trig function. So you guys remember, cosine is an even function. So what happens to the negative? It goes away. Because cosine, remember the rule is that cosine of a negative angle, the negative disappears. That was a rule, right? So that's what happens to the negative. It goes away. So that leaves us with cosine 2 theta plus cosine of 8 theta. That's it. The end. Okay. Now let's do one. Let's do one where we have fractions. So let's do we can do number 15 or 16. Yeah, it's probably 16. 16 looks harder. Let's do 16. So we have sine theta over 2 times cosine 5 theta over 2. Right. It doesn't matter what your alpha and betas are. You can do the same thing. Right. So this is your alpha. Here's your beta. Right. I got to write down my correct formula. My correct formula is going to be, let's see, I need sine cosine. I need a sine cosine. So sine cosine is the third one. There's a third line, sine cosine. So I'm going to use that formula. So, okay, so here we go. Let me write it down. So 1/2 bracket sine theta over 2 plus 5 theta over 2 plus, okay, sine theta over 2 minus 5 theta over 2. Right. And so we're going to simplify the parentheses. That's all you can do. So we get sine of 6 theta divided by 2 plus sine of negative 4 theta over 2. Right. So I can simplify it more. You get sine of 3 theta. And this gives us sine of negative 2 theta. Now, do you remember the rule for negative? What happens when you have a negative angle for sine? That one, the sign gets in front. Right? That was the odd That was an odd function, so the negative comes out. So this now becomes 1/2 bracket sine 3 theta minus now sine 2 theta. Right, so that rule, this rule was from sine of a negative angle equals negative sine theta, right? That was the rule for that. There was a rule for that. That was an even odd rule. Right? So you have to remember that when you're doing these product to sum formulas. And that's it. That's all you do. Piece of cake. Piece of cake. Okay, so we got product to sum. Now let's go backwards. Let's do sum to product. Okay, so those have a different formula. So on those, we're gonna go to page. I'm gonna flip it over. Sorry. Okay, we're gonna go to page. I don't want to say the page number, but I'm gonna have to say it. Page 666. Eek. Yep. Ooh. Light a candle after you complete this lesson here. Okay, so here are the formulas. There are 4 of them. I'm gonna write them down. They're the same as the ones in the formula sheet, but instead of using alphas and betas, they use U and V. So yeah, it's the same thing. So sum to product. I'm just copying them down. The way it's written, I'm gonna write them down. Okay, so I have sine alpha plus sine beta equals 2 sine. I'm going to put parentheses. I'm going to put parentheses surrounding the alpha plus beta divided by 2. It's easier if you do it like that. I'll show you in a minute. So I'm enclosing the alpha plus beta and the alpha minus beta over 2 in parentheses. So to make it less confusing. Okay, and then second one, I'm going to label it 1, 2 is sine alpha minus sine beta equals 2 sine big parentheses alpha minus beta divided by 2 times cosine parentheses alpha plus beta divided by 2. The third formula is cosine alpha plus cosine beta equals to 2 cosine big parentheses alpha plus beta divided by 2 times cosine big parentheses alpha minus beta divided by 2. And then the fourth one has to be the oddball, right? Cosine alpha minus cosine beta equals negative 2 sine. Sine big parentheses alpha plus beta divided by 2 times sine alpha minus beta divided by 2. Okay, all I'm doing is I'm just copying down the formulas. And remember, I'm putting parentheses around the fractions that's supposed to be enclosed with the function, the trig function. So this is how I wrote mine. It makes it much easier to do, folks, than just having them loose like that. So makes it much easier. I just surrounded them in parentheses. Okay, very simple. Again, the title matches what it says, right? Sum to product. There's the plus minus on the left, and then equals product. There's times. They're all times. Again, all you do is you're given these angles. All you do is you use do direct substitution. And that's pretty much it. So let's do one. Let's do a couple of them so you can get that. You can see how they work. So this one, we're going to start with number 17 on page, you know what page it's on. I don't want to say it. All right, so page 17. Sine of 4 theta. I hate it when they use thetas. It looks like zeros. Minus sine 2 theta. Okay, so this is 17. Okay, so again, like we did with the other one, you want to match. What does this format look like in terms of these formulas? This one's going to match the second one, right? So all you do is you plug it in. So this is your alpha. This is your beta. Alpha, beta, and you just directly substitute those two values in for your alphas and betas. So 2 sine parenthesis 4 theta minus 2 theta, right? Divided by 2 times cosine 4 theta plus 2 theta. Okay, so you want to make sure that you wrote down the problem right and the formulas right before you start to simplify it. So all you do here is you're just going to simplify the parentheses. That's all you do. So we get 2 theta divided by 2. The other one we're going to get 6 theta divided by 2. And then you simplify it, which gives you theta times cosine 3 theta. I forgot my parentheses. And that is it. That's all you do. All right, let's do another one. We can do, we'll do 22. All right, 22 reads cosine theta plus cosine 3 theta. Okay. So again, this is your alpha, and you got your beta. This is your alpha. This is your beta. Right, and we plug it in. Well, we got to find the formula first, right? So our formula matches the third one. It matches the third one, right? Because it has plus. So it's going to be the third one, right? So there's your alpha, beta. So I'm going to plug it into the third one. So 2 cosine theta, there's my theta, plus 3 theta, that's my beta, over 2 times cosine theta minus beta, all divided by 2. Right. And we simplify just the parentheses. Let's see what we get. So we're going to get 4 theta over 2 cosine negative 2 theta over 2. And then I simplify. So we get 2 theta. And this one we get cosine of negative theta. Right? So remember, we have a negative angle. What do we do? What do we do with the negative angle for cosine? It goes away. So my answer becomes 2 cosine 2 theta times cosine theta. Because remember, cosine's an even function, so the negative goes away. not like sine, right? And that's it. That's as far as you can go. You can't do anything else. You can't combine them. You can't do anything. That's it. Okay. All right. Now we got to do, let's do an ugly one. All right. So let's do, I think I'm line number 23. Let's look at 23. 23 looks kind of scary, doesn't it? Because it has fractions. It's not going to be bad. It's going to be simple, very simple. You don't have to find common denominators. It's going to work out pretty much all right. All right, so here's 23. 23 reads cosine of theta over 2. They should have put parentheses. That's just me. Minus cosine of 3 theta over 2. Remember, it's not 0, it's theta. Right? So this one is going to be the fourth. That's the fourth formula. Right? I'm going to have to use the fourth formula on that one. So here we go. This is my alpha. This is my beta. So I'm going to plug it in. So I'm going to have negative 2 sine parentheses. This is going to be very interesting. So it's going to be theta over 2 plus 3 theta over 2. It looks weird, but oh well. Times sine, I almost wrote cosine, sine theta over 2 minus 3 theta over 2 all over 2. Right, so this is 2. Let's simplify the top portion. So on the top, I'm not worried about the 2 in the bottom yet, but the top should give me 4 theta over 2. The second one, I'm going to get negative 2 theta over 2 all over 2. It's all right. That's fine. We haven't finished simplifying the top. So this should give us, on the top, 2 theta. Right? And the whole thing's all over 2. And the second one, you're going to get negative theta all over 2. I think. Yes. Right? And I can simplify still. You get theta. And I don't think we can do anything with this one. I think this one's just going to stay like that. But, uh-oh, we have a negative inside the sine function. And remember, sine is odd. So this negative is going to pop out. But we're not going to pop it out in front. We're going to go ahead and pop that sucker way at the end. And that's going to affect that sign. So we know that negative and that negative are going to, they're going to cancel out each other, right? Because 2 negatives make a positive. So that's why it becomes a positive sine theta times sine theta over 2. Right, I'm just double checking, seeing if I did it right. Yep. And that's it. All right. All right, so that concludes our lesson for 8.7.